Sagittarius A is not the quiet black hole most people imagine. For years, we were told that at the center of the Milky Way sits a supermassive black hole, silent, distant, and almost irrelevant to life on Earth. But the latest picture is much stranger. At the heart of our galaxy, 26,000 light years away, there is an object with the mass of more than 4 million suns. It is packed into a region so small that its event horizon is smaller than the orbit of Mercury. No surface, no escape, no ordinary matter as we understand it. This object is called Sagittarius A star, and for decades, scientists believed they understood it well enough. A massive black hole, a gravitational anchor, the hidden engine around which the entire Milky Way slowly turns. But there is one problem. Sagittarius A star is not behaving like the kind of monster we expected. A black hole of this size should be violent. It should be feeding. It should be glowing with the energy of falling gas and torn apart stars. It should be sending radiation through the center of the galaxy. Instead, it is almost silent. It barely eats. It barely shines. Stars whip around it at millions of miles per hour and survive. Clouds of gas move dangerously close and somehow avoid being swallowed. For something with the mass of 4 million suns, Sagittarius A star is strangely calm. And that calm is what makes it unsettling. Because silence does not always mean safety. Sometimes silence means the engine is waiting. At the center of other galaxies, supermassive black holes are anything but quiet. The black hole in galaxy M87, the first black hole ever imaged, produces an enormous jet of plasma that stretches thousands of light years into space. That jet is powered by gravity, spin, magnetic fields, and falling matter. It is one of the most extreme structures in the known universe. Compared to that, Sagittarius A star looks almost asleep, but recent observations suggest it may not be asleep in the way we thought. It may be loaded, it may be spinning, and its spin may not be pointing where scientists expected. For a long time, the simple picture was this. The Milky Way is a flat spiral galaxy, like a glowing record in space. Stars, gas, dust, and spiral arms all rotate in the same general plane. At the center sits Sagittarius A star. Naturally, scientists expected its spin axis to be aligned with the galaxy. In simple terms, if the galaxy is a flat disk, the black hole's poles should point up and down, away from the disk, into empty space. That would be the clean geometry. That would be the safe geometry. But Sagittarius A star appears to be tilted, not slightly, not politely, tilted enough that its axis may point across the plane of the galaxy instead of above and below it. That changes everything. Because a spinning black hole is not just a spinning object, it drags space-time around itself. This effect is called frame dragging. Around Earth, frame dragging is tiny. Around a black hole with millions of solar masses, it becomes extreme. The black hole twists the space around it. It pulls magnetic fields into shape. Those magnetic fields can form a funnel. And if enough matter falls in, that funnel can become the barrel of a cosmic weapon. That is how relativistic jets are born. Matter falls toward the black hole. Magnetic fields twist and tighten. Some of that matter never crosses the event horizon. Instead, it is blasted outward from the poles at nearly the speed of light. This is not science fiction. We see it in other galaxies. We see jets crossing thousands of light years. We see radiation powerful enough to reshape entire galactic neighborhoods. Sagittarius A star is not producing a major jet right now. That is important. Right now, there is no beam firing at Earth. There is no immediate disaster. There is no reason to panic tonight. But the question is not only what Sagittarius A star is doing today. The question is what it is capable of doing when it finally feeds. And the center of the Milky Way is not empty. Gas clouds move there, stars crowd there, dust streams through the region, small objects pass dangerously close. Over long enough timescales, something will fall in. Maybe not tomorrow, maybe not in 1,000 years. But on cosmic timescales, the next feeding event is not impossible. It is expected. And when that happens, Sagittarius A star may wake up. If its spin axis were pointing straight out of the galactic disk, A future jet would probably fire into relatively empty space. Dangerous, yes. Spectacular, yes. But mostly aimed away from the stars and planets inside the Milky Way's main disk. But if the axis is tilted sideways, the geometry becomes more uncomfortable. A future jet would not simply shoot above and below the galaxy, it could fire across the galactic plane, across the region where stars actually live, across the wide neighborhood that includes our solar system. Now, this does not mean Sagittarius A star is aimed directly at Earth. That would be an exaggeration. It is not a laser pointer locked onto our planet. But a relativistic jet is not a perfect needle either. It spreads into a cone. Even a few degrees of opening angle becomes enormous over 26,000 light years. At Earth's distance from the galactic center, that cone could cover a region thousands of light years wide. That is why the tilt matters, not because Earth is definitely in danger, but because the old assumption was that we were safely outside the line of fire. Now that assumption is not as comfortable as it used to be. Imagine a wall of high energy radiation moving through space at the speed of light, X rays, gamma rays, charged particles, charged. If a powerful enough burst passed through a planetary system, it could change the chemistry of an atmosphere. On a planet like Earth, the ozone layer is one of the thin shields that protects life from deadly ultraviolet radiation. A major gamma ray event could damage that shield. If the ozone layer were weakened badly enough, sunlight itself would become more dangerous at the surface. Plants would suffer, marine life would suffer, food chains could be disrupted from the bottom up. Scientists have even considered whether a gamma ray burst may have contributed to one of Earth's ancient mass extinction events hundreds of millions of years ago. That idea is still debated, it is not proven, but it shows us something important. The universe has mechanisms powerful enough to affect life from unimaginable distances. And we do not control where those mechanisms point. That is the uncomfortable part. Sagittarius A star is not just massive, it is not just quiet. It may be a tilted, spinning central engine. And if the recent measurements are correct, it may be spinning very fast. A faster spinning black hole can create stronger frame dragging. Stronger frame dragging can twist magnetic fields more tightly. And tighter magnetic fields can create a more focused jet when matter finally feeds the system. A slowly spinning black hole may produce a wider, messier outflow. A rapidly spinning one can behave more like a concentrated cosmic accelerator. That is why the science has become more interesting in the last few years. The old picture was simple. There is a black hole at the center of the Milky Way. It is quiet. It is far away. It does not matter much to us. The new picture is different. There is a compact object at the center of the Milky Way. It is massive. It is underfed. It is spinning. Its axis may be tilted. Its environment is changing. And under the right conditions, it could produce an event powerful enough to reshape the inner galaxy. Again, not today, not tomorrow, probably not for many thousands of years, maybe much longer. Human civilization thinks in years, decades, and centuries. The galaxy thinks in thousands, millions, and billions of years. On our time scale, Sagittarius A star is calm. On the galaxy's time scale, it may only be between meals. And that difference matters because when we call something a sleeping giant, we often focus on the sleeping. But the important word is giant. Sagittarius A star contains more mass than 4 million suns. It controls the orbits of stars near the galactic core. It bends space and time so strongly that light itself is trapped. It is the gravitational center of the Milky Way. Our solar system, our planet, and every human story that ever happened are all part of a galaxy turning around this hidden engine. The sun takes roughly 230 million years to complete one orbit around the galactic center. The last time Earth was in this part of its galactic orbit, dinosaurs had not yet become the dominant story of the planet. That is how slowly we move around the center. That is how huge the system is. And yet, Sagittarius A star is not some mythological symbol. It is a physical object. It has mass, it has spin, it has an orientation, it has a surrounding environment. It can change. That may be the biggest shift in how we think about it. For most of human history, the center of the Milky Way was just a bright, cloudy region in the night sky. Ancient people looked at it and saw rivers, roads, smoke, spirits, and divine pathways. They created stories because they did not have instruments. Now we do. We have radio telescopes spread across Earth working together like a planet sized eye. We have X ray observatories in space. We have infrared instruments that can peer through dust. We have the Event Horizon Telescope, which gave humanity its first image of the shadow around Sagittarius A star. And the clearer the view becomes, the stranger the object appears. It is not only a dark point, it is an engine with structure, a black hole with a direction, a gravitational anchor with a possible line of fire. That does not make it evil. That does not make it supernatural. It makes it real. And reality is often stranger than the simplified version we teach first. The phrase black hole makes people imagine a cosmic drain, something that only pulls inward, something that consumes, something that disappears matter forever. But black holes can also power some of the brightest objects in the universe. They can turn falling matter into radiation. They can launch jets larger than galaxies. They can influence star formation. They can shape the evolution of entire galactic systems. So when we look at Sagittarius A star, the question is not only what is it? The deeper question is what stage is it in? Is it truly dormant? Is it temporarily starved? Has it produced stronger activity in the past? Will it produce stronger activity again? And if it does, which way will that energy go? Those are not small questions. They change how we understand the Milky Way. They change how we understand Earth's place inside it. They remind us that our planet is not floating in empty safety. It is embedded inside a dynamic galaxy, a galaxy with ancient explosions, magnetic fields, stellar deaths, radiation events, supernovae, gamma ray bursts, and at the center, a massive object that may be quiet only because nothing significant has fallen into it recently. That is the key. Sagittarius, A star, is not weak. It is not harmless by nature. It is quiet because it is underfed. Give it enough material and the story could change. A gas cloud, a star, a compact object, a slow inward spiral over thousands of years. That may be all it takes to brighten the central engine. And if the magnetic funnel is aligned across the galactic disk, then the consequences would depend on direction, intensity, duration, and distance. A short flare may do little. A stronger burst may illuminate the central region. A powerful jet pointed through the wrong corridor could be far more serious. This is why astronomers keep watching, not because they expect disaster tomorrow, but because Sagittarius A star is one of the most important laboratories in the universe. It lets us study gravity near the event horizon. It lets us test Einstein's theories. It lets us watch matter behave under extreme conditions. It lets us understand how black holes feed, spin, and influence their galaxies. And every new observation adds another piece to the picture. The more we learn, the less Sagittarius A star looks like a simple sleeping black hole. It looks more like a patient machine, a machine built from gravity, fueled by matter, shaped by magnetic fields, directed by spin, silent for now, but not necessarily silent forever. And maybe that is the part that captures the imagination. At the center of the Milky Way, behind dust, stars, and darkness, there is an object turning faster than anything that massive has any right to turn. Its event horizon may complete a rotation in less than an hour. Think about that. More than 4 million suns compressed into a region smaller than Mercury's orbit, spinning on a cosmic axis, twisting space-time, pulling magnetic fields into invisible funnels, and doing all of it quietly while life on Earth looks up at the night sky and sees only a soft, milky band of light. We used to think the center of the galaxy was just far away. Now we know distance is not the same as irrelevance. 26,000 light years is enormous, but in a galaxy, it is still home. The galactic center is not outside our story. It is part of the system that contains us. Every atom in our bodies exists inside the Milky Way. Every sunrise happens in orbit around Sagittarius A star. Every civilization that has ever looked at the stars has done so while circling this hidden engine. That is why this matters, not because panic is useful, but because wonder is, and because the universe becomes more honest when we stop pretending it is safe just because it is beautiful. The Milky Way is beautiful. It is also violent. It is ancient. It is alive with motion. And at its center sits something patient, quiet, and powerful enough to change everything around it when the conditions are right. So, the next time you see the constellation Sagittarius in the summer sky, remember what lies in that direction. Not just stars, not just dust, not just a glowing region of the Milky Way, but the heart of the galaxy, a compact object with millions of solar masses, a black hole that barely feeds, a central engine with a tilted spin, a cosmic machine that may be waiting for its next meal. And one of the biggest unanswered questions in astronomy is not whether Sagittarius A star exists. We know it exists. The question is what it will do next. And when the engine at the center of our galaxy finally wakes up, the most important question may be very simple. Which way will it fire?